So welcome back for another hacking session on the game. And in the introductory video, we created a very simple game, right? And I've been working on it a little bit more. And as you can see, the little creatures start, like say, finding food and they grow. And the whole idea is essentially that they want to find food, and then once they found food, they will move essentially towards each other and start eating each other, right? So as you can see here, the part that has 88, so it's like swallows everything up, and the 37 swallows also everything up. And this is a way essentially that in the end there's only going to be one left, right? So this big thing is going to swallow everything, and it's going to be dominant essentially, right? So now I don't like it. Let's say so what I'm working on right now is making it in a way that I want the world to be very big, and I want this white thing, which is now being controlled with my mouse keys, I want it just to move in the center of the game, and then when I move around, essentially I get the same. Let's say I'm moving over a bigger world than is defined here, right? So to do this, I need to rewrite the code to the next phase, and then I can make those creatures like move in a bigger space. So this is like a short hacking session, like implementing this again in the MacroQuad library, which I'm really starting to enjoy. So let's start with implementing this. Let's do like this. So here we use like the screen width and the screen height. So we're gonna replace this with a max X and a max I. And we're gonna pass those in as a argument. This will be float 32-bit sized, because they are like everything in MacroQuad essentially is sized like a float 32. This is the float comparison function we saw in our earlier implementation in the previous episode. And now we get some errors because of course I use it everywhere. So here we have the choice to create a random creature. So either we pass in the world, and store the world inside the creature, so we can run this update function on it. Then it has essentially absolute awareness of the world. This is something. This then should be a borrowed value. That won't fly in Rust, because then we borrow that value out in other. Let's say we cannot have like a mutable one. We cannot mutate it anymore. The world needs to be mutated at some point, so that won't fly. So here we need to make the interfaces very specific. So here I'm also going to do like the max X and the max I, because this is like what's needed to place like a creature randomly in the world. So we also have like a float 32 and again a float 32, and we're gonna specify it here, max X and max I. Okay, perfect. Let's see another error. That's here. Creature here also needs a max X and a max I. So here we already have width and the height of the world, right? So we are going to define it here. So the width is again float 32, and we have a height, which is also a float 32. So now we can use here the creature, but also a width and a height. So that's perfect. And the width and the height we can create it here as a config, or we can set it like fixed. Let's just do it like this, width and the height, both F2, so F32, and we place that here, with height. We also define it here, width, it's the width, and we have the height. And of course we can do this shorthand. So a random creature with width height is being placed, and we set some food. The food also needs to have the width and the height, so let's just add it, width and the height, which of course will give an error right now. So let's go to the definition. And we have max x, max y, and we're going to add it here as well, max x and a max I. So now we should have a world which is bigger. What's the problem? Expected colon I, of course. We need to specify the types. So now we have a world which can be bigger. So here this is, where is this? Is this in the world? Self width and self height. And of course, we need to somewhere. This is another thing that's really nice about programming in Rust, is because the type checker is so thorough that you just like keep on, let's say, it keeps on guiding essentially where to go. So I want to have a big world, right? So I want to have like multiple screen sizes. Just I want a very big world. So of course we start at the coordinate 0, 0, but then in the end, let's do a reasonable square. Let's do 5 times 24 and 5 times 1024. And of course we need them to be floats. And here the same, right? So, and now we have essentially a new view of the world. So let's see how this works. And it seems to work, because now we have like only one dot here. So the rest of the dot is spread all over the place. So, but no creatures are visible here. So now if I have this little white dot and I want to go up and down, I want the world coordinates to move essentially with me, but essentially moving around here. So essentially what it says is I want the player position, which is defined here, to determine how essentially this world is being rendered. So we're essentially moving the inside of the animation. So to essentially give you an idea, what I mean is that we have like a big rectangle, for example, This is now the world. Which let's make it a bit smaller. Which is the world, which consists out of 1024 times what is the size here? 16. And then inside we have like a little piece of the world, which is like this. And this is essentially our screen area. And we have our little creature, so 10%. And we have our creature, which lives essentially inside this screen area. So we have an oval, which we would give like no border, give it like a white color. And this screen area is somewhere placed essentially in here. So if we group this, then we will move, so like left or right over this world, and displaying all the creatures or all the food and everything that's there. So we could say, if we place it here, and we would take this as a thing on board, and we would essentially group. So this is the screen area, the rectangle and everything is on top of everything. Let's group this together. Something, and we'll lock this. So essentially we could say that we have like an offset here. Like this is position X and position Y, right? With an arrow. This is, Jesus, I need to make this smaller. 12. So this is now player pos X, and we have player pos I, player pos I, which is in the center, and then we have this, for example, the screen is for the screen width, and we have another part which is screen height. And what we want to do is move this over here, right? So we have here, it's very interesting. So this is like the range here is that this screen area can move all the way to here, which essentially that means like the offset is 0.0, right? And if you want, or we can move all the way to here, which means this is like 1024 in this case, minus, so where we are here essentially is minus the screen width. So essentially we have this width and this height, and this determines essentially the range where everything can move from that perspective. And you could argue that that range is this rectangle, right? So these are the valid areas where it's safe to move essentially, right? So let's make it a bit like this. So this screen, right? So this screen area can move all the way in this coordinate system. So everything that's valid is between 0 and, let's say, the width of the world, which is now 1024, minus the screen width and the screen height. So let's let's just group this a bit so it makes all sense. It all makes sense. That rectangle should be underneath, and it should also be locked. And then here, no, it should be unlocked. The rectangle should be locked. So here we have the screen area. Yeah, and I wanted to get this all included. So we have this. Yeah, we can move it like all the way around. So this is the valuable range of these coordinates, and let's just, for now, to make it simple, we'll just place our player in here. So we have, like, if we zoom into this area, we still have a few set of arrows. I'm just going to make it inside of here. There's arrows, and that is from the screen area, right? We have these coordinates, like here, another vector that essentially points to this center, which also consists out of an x and an y component, which is the center, right? It's the midpoint essentially of the screen area, which is here, which will just make it dark green. So this midpoint and this midpoint. So let's copy it. Let's get it here and here, and we are done. So mid. So I'll just type a nice big M to the side here. This is the midpoint of this area. Make it a bit darker. Midpoint, and we have another midpoint here. So if we see this, then taking everything into account, we have the screen area here. We thought it was all included, but move like this. So here, essentially, we could say we start here in the center of the world. That's a nice thing, right? That means we have the world. In the midpoint of the world is the midpoint of the screen area, plus here. And then we can, if we start moving, our valid range is all the way here, until here, until here, until here. So essentially we're moving this square around. Okay, I hope that's clear. So let's now implement this. So this all has to do with the rendering of the world, one could argue. So we're just gonna close this one. So here we have the world, and this is being rendered. But now it has to also take into account this square with screen width and screen height. So we are moving everything with a vector. Everything we render here is rendered with a vector based on the player position. So we could say, so we have the beginning of the world, and we're going to make like a fat vector here. That if we are rendered here, and we actually start at 0, 0, of course, because this is like how it works. X and I. So I'm going to make a fat one. So this one, this vector determines essentially where to render our player and everything else of the creatures. And of course we have some natural clipping occurring. And this is identified with the player plus X and the player plus I. That identifies this vector. So How are we going to do this? So if we, let's say, if what we saw before when we executed it, right now, we have it here as, here's the point 0.0, and then we move essentially to, you know, like this 1 point is plotted, right? But now if you start moving, I want this offset, right? So I want this offset in the middle. So we want this point to be always in the middle. So how do we do this? We essentially do the following. So what we actually do is we transform every element So if the screen area is here, we transform every element to the negative of this thing. And this thing is always the midpoint of the screen area. So if we define this in the render function, we can say that the midpoint of x is screen width divided by 2, and the midpoint of y is screen height divided by 2. And then we have the position of the player. So, but that should essentially, yeah, exactly. So we can say the transformation we need to do. So this is one transformation, it's a screen width, it's this to the midpoint. So let's do this like m. It's a new vector with mx and mi. And then we have the world. Now we have the position of the player is the other one. So, because if you would like transform to the position of the player, it would be easier. So now we need to render it with a transformation, right? So that means our render definition here needs also to incorporate a transformation of the renderable based on the world, based on the position. So we need to implement this. So we have render with a transformation. Which is also a vector. And we get, I think, a few errors. Render with the transformation. The vec. Two. Now we have here the pulse on the eye is now being transformed, so this becomes now plus, right? So the end position, so let pulse is self pulse, and we add now transformation, and then we just remove the self here. Perfect. and now we have it adapted. The same we do here. We also take t, which is a vector of 2, and we are going to do let pos is self position plus t, and we are going to remove the self, and we have another renderable, which is creature, which also has a transformation, and we are going to remove the position, and the same for this one. Okay, I get some errors here because I didn't define the pos yet. Is self pos plus transformation, and now we have radius. Self, it's my mistake. Again, wonderful from the Rust checker that defines it that quickly. 10 more errors. So the world is also renderable, but I'm gonna, because we don't need to like give the transformations here, right? We could do it. Let's do it first like this. Effect 2. And we'll just ignore this one, right? That's what we do, we don't need it here. And then we have, okay, so now we need to apply this transformation. So let's first do everything so the transformation is, we need to do the negative transformation of the player minus this, right? So we have the what is that? Self dot player position. We do minus this the m, just to be sure, right? So we have this position, then we do minus, we're here, and now this one should be inverted. And then we invert it, so this whole thing, we do it times -1 t, then it's render t and t, so we get, yeah, of course this needs to be a float. And we also have to rate the player also has to be transformed. Does it? Yeah, because we need everything in that screen area. 2 more errors to go. That's the world. It also needs a t. This is what I mean, right? Because we don't really need it. So what I'm just going to do, I'm just not going to implement this renderable for the world. Oops, this one. So I'm not going to do, I'm just going to make this an implement world. Then I can change this into a normal one. And then it should work. Perfect. So let's execute it. And look at this. We have something working on the screen. So now we're moving through this world. Look at this. And here we have a little creature that's moving. But it's moving really slowly now. We can circle it. And we could eat it, right? So if we will be able ourselves, we can eat it. So, but this is a little bit on the heavy side. So let's make the world a bit smaller. Let's make the world 2 times, so it's a bit bigger. And what is nice to do, rendering the world, is to make it just for our case, we're gonna make a red, make a black, because that's the end of the world, right? We'll make it black, and the world, when it renders, we are going to draw a big rectangle, right? We're going to draw a big rectangle over the world with the width and the height. So we have draw rectangle. Draw a rectangle and xi with height, okay? So we draw a rectangle here at 0 point, 0 point, and then we take the width of the world and we take the height of the world. And a color. This now will become the red. So now we have an idea of what the borders of our world are. So everywhere is black, that's the end of the world. So we start, let's move. You already see a little bit more moving around. So let's explore the end of our world, if we can find it. Maybe we'll just increase the speed a bit here, because it's hard to find. 2 times 2 times. So we're gonna like really bump it up. So we're gonna go fast. And we're gonna move for the speed of 50. Because I just want to see where the black starts. Interesting. I don't see the black appearing, so I'm missing something here. So because we have here the rectangle with red, so let's make it purple. Just to be sure I'm not doing anything wrong here. For the purple world. And our position x and position I in the beginning is 0.0, right? In the player. It's not in the player position. Yeah, because this of course this rectangle also needs to be transformed, of course. This is what I'm missing. I have to move everything around. So this transformation is now t.x and of course t.i. And I like the red one. Okay. And there we are. So here you can see ourselves moving through the space, a big world which ends at the boundaries, and we can like move very quickly through the world. It's a bit too hard, the movement, so let's make this go a bit softer. Let's make it 5. Because those creatures are also not moving that quickly. And the speed of those creatures is also not that quick. Eh? So direction here is okay. So it's really, they're moving pretty slowly. Let's also give them some speed, because the world just became bigger, right? So let's see the move. Yeah, that's better. Oh. Now I find myself moving a bit too slow in this world. Jesus. These are growing pretty quickly. So what happens if I resize my window size? Oh, that's cool. So now I can make it big. Now we really get the feeling that we're like almost playing a game, right? Now we're just moving very quickly. Look at this. Now we can even... Now we have the feeling I'm a part of the ecosystem. So here, for example, I would have been eaten already. Like, if it will be a little bit bigger, and I can compete with the rest. This is pretty cool. This is pretty cool already. So this is a very nice addition to our game, right? So let's oh, geez, I need to escape these animals. So let's the next episode I will go and make, let's say, the player itself also a creature, which also needs to survive, and we are going to make those creatures a bit more intelligent. So I hope you enjoyed this video cast. So please like and subscribe, and let me know what you think about the game and what you would like to see in the gameplay, and what you think about the MacroQuad engine and how it's built and how fast it compiles, how fast you can get results, and if you like it. So let me know. Okay, bye bye.